Hello, everyone. This is part 4 for the limited states of compression steel. From the code, the code 360 version 10, the code has organized it according to their provisions. So first you have the flexural buckling of non-slender members. Then you have the torsional buckling and a flexural torsional buckling of non-slender members. Then you have the single angle members and slender members in general. So working with the limited states, we have first to identify if we are working with elastic or inelastic column. And then according to this, we have to use the general equation, which is the nominal compressive strength equals the stress, which is the flexural buckling times the gross area. So we're always going to use this equation here to be able to identify the limits of the limited state of the compression steel. So for calculating this, actually the phi times the F sub CR, which is the stress, could be found from a table, which I'll show you in a minute, or could be just determined manually. So if it's manually, then first you have to identify your region. Is it inelastic or elastic? And the way we check for this is first we have to find the slenderness ratio, the KL over R. If it's less or equal than the 4.71 times the radical modulus of elasticity over Fy, then yes, it's inelastic. Then your F sub ER should be calculated from this equation here. And the Fe, which is Fy over Fe, the Fe is calculated from this equation here. If your region is elastic, and you should check for that by the slenderness ratio value should be larger than this, then your F sub CR should be calculated from here. That's the manual approach. Then for this value here to check against the slenderness ratio, it could be also found from this table, the 10.3, from the steel type. So if you're giving in the problem statement the steel type, then you can just find the value from here without using the equation. Sometimes you're not giving the modulus of elasticity, that's something you always have to memorize, which is a 29,000 KSI. And the Fy should be given. But in case if this is not given or you want it to be more efficient, then you can just jump into this table and get the value from here according to the steel time. Here, from this table 10.4, you can find the phi sub F CR from the table, so you don't have to calculate it, like I said. Basically, you have to calculate the KL over R, and then you have the equivalent value here. So the table here consists from two values, KL over R, which is the slenderness ratio, and the phi F sub CR, and so on and so forth. So you have two options, whether to find them from the table or calculate them manually.